Metals like aluminum and copper are part of our everyday life in utensils, wires, cars, and smartphones. But most production still follows a linear model, which means materials are extracted, used once, and then discarded. This approach consumes huge amounts of energy, depletes resources, and creates harmful emissions. For example, producing new aluminum requires up to 20 times more energy than recycling scrap aluminum. That makes the current system both inefficient and harmful for the environment.
To evaluate such impacts, industries rely on a method called Life Cycle Assessment or LCA. LCA is an international standard that measures a product's footprint across its entire life cycle, from raw material extraction to processing, use, and disposal. But current LCA tools are often too complex, data heavy, and costly. Many also fail to capture circularity opportunities, which means alternatives like recycling, reuse, or remanufacturing are not properly compared to the conventional one time use model.
This leaves industries with two major hurdles: data gaps, which means key inputs are incomplete or inconsistent, and usability issues. Existing tools often demand trained LCA experts. As a result, decision makers don't get simple, reliable insights, and sustainability opportunities are lost.
Our idea is an AI powered lifecycle assessment platform designed for metallurgy and mining. It works in four steps. First, data ingestion, which means collecting data from spreadsheets, ERP systems, or factory sensors, followed by AI gap filling, where machine learning estimates missing or unreliable values so the analysis can still move forward even with incomplete data. Next, impact assessment, running sustainability calculations using databases like EcoInvent and USLCI along with Indian datasets to measure energy use, emissions, and recycling potential. And finally, outputs, presenting results in role specific dashboards and creating ISO 14040/14044 compliant reports that managers and policymakers can directly use. The platform also supports scenario testing, for example, simulating how a 10% reduction in plant energy use changes the overall footprint.
Unlike traditional LCA tools, our platform is data gap tolerant, meaning it can still work with incomplete data by using surrogate AI models. Circularity focused, which means it compares both conventional and recycling based pathways instead of only the linear model. Localized for India by integrating regional datasets for higher accuracy, role specific, with dashboards tailored for metallurgists, planet managers, and policymakers. This combination makes sustainability analysis intuitive, reliable, and accessible even to non experts.
The impact is measurable and multidimensional. Economically, recycling aluminum cuts costs up to 95%, while formalizing e-waste could unlock $3.6 billion in value for India. Environmentally, using 1 ton of steel scrap saves 1.2 tons of ore and zero point 0.5 tons of coal, while reducing CO2 emissions by nearly 60%. Socially, reducing mining pressure helps protect forests and tribal communities while creating new opportunities in India's recycling sector. We are Tech Titans MVGR. With our AI powered LCA platform, we make sustainability practical, affordable, and impactful, turning metallurgy and mining into engines of circular future of India. Thank you.